Hello, my name is Wei-Yen Lin from Department of Civil Engineering,逢甲University. The topic I'm presenting today is automating the generation of indoor network for human wayfinding using 3D GIS. In short, I'm going to introduce an algorithm that I propose to generate the indoor version of Google Maps. Most of you probably have the experience of getting lost in large public buildings such as metro stations, railway stations, airports, or large shopping malls. Even given direction signs everywhere, people still find it difficult to find their ways. I was born in Taipei and lived there for over 30 years. When I visit Taipei main station, I still get lost from time to time. That's probably because the current indoor wayfindings for human beings is still highly artificial. For example, here's the floor plan provided by a shopping mall. It gives you a map and a long list of indoor spaces. Obviously, people still need to figure out their ways by themselves. Nowadays, public buildings may provide 3D map like this. It looks straightforward, much easier for humans to understand the indoor layout. But how about this one? For those buildings with complex structures, like Taipei Main Station, the static map, either 2D or 3D, is still not good enough for citizens in smart cities. What if we have an indoor version of Google Maps? You simply type in the origin and destination of your trip. The system automatically gives you the shortest path from point A to point B inside the building. Let's have a look at how Google Maps finds the shortest path. First of all, it requires a street map. More precisely, it is network dataset that stores geometry and attributes for each segment of street. With the network dataset, the algorithm can calculate the shortest path in terms of distance and time. How about indoor environment such as buildings? Similarly, it requires indoor version of street map. For the past 15 years, 3D modeling technologies is quite mature. When you're modeling a building, you create the structural components like columns, beams, slabs, and walls, etc. You don't really create indoor paths like this. If you want to create indoor paths manually, it's gonna be time and energy consuming. And it's also very easy to make mistakes. So about 3 years ago, 2018, I proposed an algorithm called iGit to automatically generate the indoor paths or the indoor version of Google Maps. The only input for the algorithm is the 3D model. It has to be in a standard format called RFC. There are 3 steps in the entire geoprocessing workflow: identifying indoor spaces, generating floor level path, and generating non-floor level path. Here's the example of indoor paths created by the algorithm. The upper right on this slide is the floor level path, and the rest of the slides are non-level paths, including stair path, ramp path, and elevator path. In following slides, I'm going to introduce the logic of algorithm to create those paths very briefly. Phase 1. Identification of indoor spaces. The algorithm first intersects the horizontal components like slab and vertical components like walls, columns, and doors to generate the partitioning areas of indoor spaces like this. Next, the algorithm cut the entire boundary of slab by partitioning areas to generate the indoor spaces. And the centroid of each indoor space will be the node that indoor paths must go through. Phase 2. Generation of lower level paths. The algorithm then divides those indoor spaces into triangles using Delaunay algorithm, and it connects the midpoint for each internal side of triangle to form the path for those indoor spaces with irregular shapes. And finally, the algorithm connects the endpoint of the paths created previously to the nearby doors to form the entire floor level path as shown in this slide. And phase 3, generation of non-level paths. This is the major part of innovation of iGate algorithm. The following innovation explains the complex logics of the algorithm to generate the stair path. The first version of algorithm only supports the stairs with straight flight, and the later versions of algorithm continue to support other two categories of stairs, including wider stairs and spiral stairs commonly seen in public buildings. As mentioned before, the indoor path is the key to the indoor version of Google Maps. So here's the example of indoor paths created by iGate algorithm for high-speed rail Taichung Station to demonstrate the application of indoor paths. Here's the systems we create for the demonstration. The origin of the scenario is Taipei Main Station and destination is National Taichung Theater. The systems will give 3 suggested trips from origin to destination. All of them include high-speed rail and then take a bus. By clicking the high-speed rail icon, the systems will direct you to navigate the entire shortest path calculated by the system. You can navigate the path starting from you get off the train and down to the level of gate, and then take a route on your left hand side to exit the gate and continue to move forward to level 1, where you can take the bus. Other applications include campus direction systems in Pengjiang University. Similarly, you type in origin and destination of your trip, and the systems will calculate the shortest paths for you, including outdoor paths and indoor paths as well. Currently, the system can only make a route plan for you to reach your indoor destination. But in the future, if we have more mature indoor positioning devices like a GPS for outdoor, we can also do the real-time indoor navigation as we do with Google Maps for outdoors. So this is all my presentation today. Thank you for your listening.